Declan wants to join on stage. I mean, it's my colleague Declan. Round of applause, please. Thank you. And thank you so much, Cheryl and Eunice, to give me another opportunity, to give us another opportunity to talk about service mesh, which seems to be not super popular, but that's what I always say. I'm on a mission to install a service mesh on every Kubernetes cluster. Don't leave your clusters alone with me, because you're gonna find Istio afterwards. Because I think it's we're gonna try to convince you that there is some logic behind choosing to install a service mesh in your cluster, and that's why we are here. So I've given a presentation about Ambient Mesh at this very meetup. I think it was January or December. It was very cold and not like today. So I'm just gonna go very quickly through the concept ideas behind service mesh, what is service mesh and what is ambient mode for Istio. So please bear with me. We have 45 minutes or 30. Great, no problem. And so I'm Alessandro. I live in the Netherlands. I'm Italian, as you can hear from my accent. I'm a developer advocate, platform advocate, a solo CNCF ambassador. That's where we met at the also my meetup. I also run the Dutch Kubernetes meetup, also 6 years old. So it seems to be a trend. And Declan?
Hi everyone, Declan McAleese. So I'm also at solo.io. I've been working with cloud native software for about 5 years now, starting at Pivotal and VMware, and now I'm working at Solo as a field engineer. So a little bit on the cold face sometimes, and yeah, we're understanding a little bit more about how service mesh adoption is going.
Super, thanks. Give me some help, because we're gonna go very deep into the networking stack. So be prepared for some serious iptables rules to are gonna show. So we're gonna talk about CNI. What is CNI? First of all, what is service mesh? What is ambient? And how the traffic in this particular mode of Istio, so the ambient mode, works, right? So this is all quite technical, so bear with me. I'll try to get some terminal action later on. So this is all based on, we have a great academy. Of course, everybody is an academy today, so academy.solo.io. We have a workshop. We have many workshops, including like a basic of service mesh. You can get certification, nice little Credly badge to show to your friends. We have a specific workshop base called in-depth routing analysis for Istio, done by my esteemed colleague Peter Janusovic from US. Is a great guy. It goes very deep. So I'm just trying to squeeze 2 hours workshop in 30 minutes. Wish me luck. So this is the QR code. It's gonna be available for 7 days. But let us know, get in touch with me, Declan, or Scott over there if you want to know more about this stuff. And we will really like you to learn, because it's we believe this is a very good occasion to do it. So you can get a badge, of course. About us, about Istio. So Istio is one of the most popular service mesh. I wouldn't go. I mean, I don't want to. Of course, like blow my own pipe, but Istio is one of the first service mesh on the market. It's an open source project. It's been now proposed for graduation. It's been accepted in CNCF. For a long time, it wasn't. It was part of there was a specific foundation that managed it, but now its part is under the umbrella of the Cloud Native Computing Foundation. So it's fully open source, managed in the open. There's a great community around it. I know 50% of the people here don't use it, but chances are, if you use service mesh, you probably are on Istio, as many years of adoption used in production by many customers. And of course, we would like you to be part of the community. So just go to GitHub, Istio/Istio. We have a channel on the CNCF Slack, but it's a very vibrant community, very mature product. So much so, recently it was one of the quickest journey in CNCF. So it was adopted by CNCF, and almost right after Istio project applied for graduation. As you know, graduation means that a project is really mature. So we hope that soon, very soon, we can call Istio a graduated CNCF project. But Istio is a service mesh, and it's traditionally based on sidecars, right? So if you know the sidecar model, right? So it's about embedding a proxy into every single pod application that you run. So that's the mesh, right? It's the mesh of proxies. They are intelligently managed by the control plane of Istio that does the magic. So once you have a proxy embedded into every pod as a sidecar, right? So the sidecar model, you can set another container in a pod that can intercept all the networking for the application and does the magic, like layer server policies or introducing fault injection. All sort of interesting features of the service mesh are done traditionally with the sidecar model. It was great, and it runs fine, and most people use this. Of course, like this is production, the stable version of Istio runs this, right? So runs the sidecar model, which is pretty good, and also in our product at Solo, that's what we do. We have a product based on this. But of course, we realized, the Istio community realized that maybe a blocker for adoption is indeed this cost associated with running sidecars on every single application pod in your clusters. So these sidecars are based on Envoy. Envoy is another CNCF graduated project. It's a very small, very efficient proxy, written in C++, I believe, or in Go, not sure. But it's very, C++. So very, very fast and efficient, but still with some memory footprint and CPU footprint, right? So you do waste CPU cycles and memory just by running Istio. So this was probably one of the reasons people were a bit resistant about adopting service mesh. And so the new way was announced in September 2022, really not too long ago, is this mode of deploying Istio called Ambient Mesh. So what is it? What does it do? A very, very brief introduction to Ambient Mesh. We get away with the sidecar model, and instead we run a proxy per node. It does exactly the same thing, intercept traffic out of the application and redirects it, and does interesting things like mutual TLS between the proxies and so on. So it does exactly the same thing. So as the full features of Istio with sidecar, minus all the complications. So injecting sidecars into every pod, which means you need to have a admission controller that modifies the templates as you give your cluster the specs of the deployments of the pods. That goes through an admission controller that injects another container into every pod. So you get rid of all this complication, all the complexity, with a simple one proxy per node model. Does exactly the same thing. So it gives you all the feature of service mesh, of Istio, mutual TLS, and traffic routing, and all sorts of things, without the price that you have to pay to run the sidecar model. So less complexity, less stuff that can run, which means also more secure. Imagine there's so much attack surface here because you have a lot of these proxies, and here you just have one, right? So it's less attack surface, which makes it implicitly more secure than the sidecar model. And please correct me or ask me if if you have doubt about it. So in service mesh, of course, you get the basic layer 4 processing, right? So the OSI layer 4 is the transport layer. So it's just for example, the network policies based on IP addresses. So these pods can talk to these pods. This is layer 4 processing, layer 4 traffic. You get the same. But then in service mesh, one of the best features is layer 7, so more sophisticated proxying. Envoy does it because Envoy is both layer 4 and layer 7 proxy. And we leverage this in the sidecar model to do some interesting layer 7 application networking. We do the same in Ambient, nothing changed. So that's why feature parity, nothing really, you don't lose anything by running Ambient. The only decision that was made was to split the layer 4 processing from the layer 7. So in this case, in the sidecar, the proxy that sits next to your application does everything, right? So it's Envoy, so it's controlled by the control plane, it's programmed, the Envoy filters, Envoy rules, and routers are programmed by the control plane and does everything, both the layer 4 and layer 7, but it's not very efficient because you need to run a full Envoy proxy for everything. While in ambient mode, you have a layer 4 proxy sitting on the node, does all the plumbing like mutual TLS and all sort of layer 4 part of the routing. But if you need layer 7, there's a specialized proxy called waypoint proxy that is dedicated just to that job, the layer 7 processing, and is more efficient because you don't need it when you don't want layer 7, and can be deployed per workload identity, right? So we are moving away from application identity based on IP addresses or where they are. So this is part of the zero trust security ideas, right? So now we assign an identity to every application, and based on that identity, the layer 7 proxy will make a decision. This application can talk to this application over these protocols, over these routes, and so on. So this layer 7 proxies, we call it waypoint proxy. It's also based on Envoy, does the job, it's a very specialized job of processing all the application networking policies, and is deployed one per application workload identity. So in Kubernetes, this most likely corresponds to the service account. So if an application is a service account associated with it, that's what you get. So it's more flexible because you can do more things. You can do more things with less footprint, and we believe is actually more performant because you have more connection through one proxy than distributed over many. So this is going to be part of our product as well. So I work at Solo. We work at Solo. It's a great company to work for. If you are into Istio, we actually are very much involved in the Istio community. So we really love the project. We work on it. We spend a lot of time making it a very good project. That's why we're really glad that it's going to be graduated. And we're gonna implement Ambient Mesh also in our product, which is glue platform, which is made of many different things. There are many, we have many different ways to help you out in application networking, from gateway and portals and so on. So, but let's not talk about too much. But please reach out to us, and we'll show you what we can do. So, CNI. Who knows? Okay, I was talking to somebody who was a CNI maintainer, so thank you very much. So if I say something stupid, please correct me. So CNI is, it's called, CNI stands for Container Networking Interface. It's a way for Kubernetes to interface with network plugins. I remember before the CNI, there were network plugins, right? So they were very specialized. They were sometimes in tree, so in the Kubernetes tree, while this is not what you want, because there was a lot of churn and a lot of waiting time before a new patch for a network plugin would be accepted. So Kubernetes project decided to adopt this interface, this API called CNI, and that it's made more simple to implement different network plugins as an external program that gets called whenever Kubernetes needs to create a pod. So this works very simply. Every time you need to create a pod, you make a call to the API server. The API server just talks to the kubelet. The kubelet takes the job of creating this pod, right? So, of course, it talks to the through the CRI, the container runtime interface, talks to the container runtime, Docker, CRI, or Podman, whatever, or Containerd or whatever. But for the networking part, this is how it works. So it calls an external binary script. There are many tutorials online. You can actually build this as a bash script or write something in Rust. Anything that can create the plumbing, the network interfaces, the network namespaces, they are part of the pod, can be used as CNI, right? So I've seen people doing crazy stuff like making CNI with bash, right? So it doesn't matter how it's done. The Kubernetes just calls the CNI and reads a config file, of course. There's a config file for every CNI, very specific. And it's written in YAML, by the way. And the CNI binary is called every time there is a operation like pod creation, deletion, or modification. So the CNI takes care of plumbing that pod through a network namespace and creating the interfaces. These are mostly virtual interfaces, virtual Ethernet pairs between the network namespace and the node interface. So this is very quickly how a CNI works. So in Ambient Mesh, every time a new pod is created and is part of the mesh, this needs to be plugged in, right? So it needs to be literally plugged in, right? So we have a thing called Istio CNI that takes care of this job. So before, in the Cycle model, we had something called Istio init, right? So Istio init was a init container injected into every pod that was part of the mesh. It still is, of course. It's still, if you use the Cycle model, you still get it. And you will see every time you look at the pod, there are a bunch of new containers in there. One is the proxy itself, Envoy, and one is the init container that does the plumbing for the pod. So it creates all the IP tables within the pod. It takes care of the networking between the proxy and the application container and the outside world. So it writes IP tables so everything is intercepted by the Envoy proxy, and then all the communication is done through the proxy. So it's works, but it needs to have privileged access to the host. So the net host privileges, because it needs to literally plumb and plug all these virtual interfaces. In the Istio CNI world, in the Ambient Mesh, there's a specialized daemon set runs on every node called Istio CNI. You will see. I'll show you. Just when you deploy Istio in ambient mode, this gets deployed as part of the pre-configured template. So Istio CNI provides the plumbing at the node level between all the pods and the layer 7 proxy, which I forgot to say that it's called Ztunnel. Any question, please interrupt me, raise your hand, say anything. All right, so every time a new pod and a new Ztunnel is created, this Istio CNI provides the plumbing. So now this part of I had the same problem that I had to type. So this is also part of the tutorial, the workshop you can follow. You can do it yourself, of course. It's self-paced. It's actually, it looks like this. It's an instruct. It's on instruct, so you get all the explanation on the right, and you have a cluster here that you can use to do your test, of course. But I also like to have my own. So you can see there is an Istio CNI, and I can also switch to my own. It's kind, so it's Kubernetes in Docker, so everybody can use it. It's very simple to test. So there's an Istio CNI daemon set that it watches for new pods that are created on the node and does the plumbing. So there's a whole explanation what's going on. So for example, and so in let's see if I can show you. Yeah, so as you can see there is a Istio CNI daemon set and there is a Ztunnel daemon set. So these are 3-node cluster: control plane, worker 1, and worker 2. So every node gets its own Ztunnel because it's part of the it needs to be there for when you have a pod that is part of the mesh, it gets the traffic. So, and the CNI just is there to set up the network interfaces. So if you look at this, so when a Ztunnel pod is created, right? So these are the virtual interfaces that are created when the Ztunnel is deployed on a new node. So when you, of course, it's been a daemon set, you scale the cluster, every new node gets this. So there are a pair of interfaces called P Istio out and Istio out. So P Istio out is the pod side, right? So and Istio out is on the node side. And these are connected through a technology called GNIV, generic network virtualization encapsulation. Is just a way to connect a pair of virtual interfaces. So it's all done transparently by the CNI. So the Istio CNI provides this plumbing. So, and let's see. So how do you check these things, right? So first of all, I deployed already because I wanted to get done quickly. So there's a default namespace, of course. And if you look at the namespace, you can see that this namespace has a notation. Where is it? Default. So the default namespace has this label. I labeled the namespace, which means it instructs the Istio control plane to make sure that every pod in this namespace is part of the mesh. So I either label single pods, pod by pod. Normally we onboard entire namespaces to the mesh. So automatically all these pods are now part of the mesh. What does it mean being part of the mesh? In the sidecar model, this means this instructs the admission controller to inject the container in the pod definition, but in the ambient mode, it doesn't really change the pod definition. You can see because in so there's still one container. So this HTTP bean is just a simple server. It only still contains one container. So once I am on board this namespace on the mesh, this pod doesn't need to be recreated, doesn't need to restart. It just keeps working just as before. So I don't even need to, in the sidecar model, I need to restart the pod because, as you know, you can't inject a container in a pod without restarting it. So that's a big thing. You can't really do anything unless you restart the application. But in ambient mode, this is completely transparent because the networking, the packets coming out of these pods are now hijacked, are now intercepted by the layer 4 proxy, the Ztunnel, in virtue of the Istio CNI plugging in the right way the pod into the Ztunnel. Also, how does it work? It's a bit complicated. That's where we get more technical, which is I love, of course. So this, I'm listing all the interfaces on the node itself. Because this is one of the nodes, of course, on the cluster. So in kind, every node is a Docker container. So I'm just getting into I could do the same with SSH if I was running on on a cloud provider or something like that. So I get a bunch of these virtual Ethernet pairs. Some of them, of course, they have CNI. So these are part of, so these are virtual Ethernet, virtual interfaces that are part of network namespaces. So network namespaces, so I'm listing now network namespaces on the nodes, because there are 3 pods, and you can see there are 3. So the pose container is the one that holds the network namespace. So I have 3 network namespaces on this particular node, and you can see these names here. So now I'm using this command. So ncenter is a Linux command that lets you get into one of these namespaces, right? So I'm getting into the namespaces, and I'm actually checking what are the interfaces inside the namespace, right? So I have a, see, yes. If you look at this simple diagram, this is how it works, right? So inside a pod, there's always a virtual interface inside the pod that corresponds to a virtual interface outside the pod. And there's this is the magic that lets the connection between the pods and the network of the node. So you can see that from the point of view of the pod, this is the IP address. There's eth0, so it's very standard. So there's every pod knows that you can rely on eth0 to be present on the pod, and that is actually connected to the other side with a virtual Ethernet interface. And if you can tell, because this is a CNI 85 something something, and this is the virtual Ethernet that is on the other side, right? So this is all done by the CNI. So by the whatever CNI is using, this does this plumbing between the pods and the interface. And so, and then you can also, so we say that on this node, there are 3 pods. One is definitely the HTTP bin, and the other ones are actually is the Ztunnel, the 853. I checked it myself before for the demo, but trust me, this is the Ztunnel, because there are this, see these interfaces, P Istio out and P Istio in. These are these, right? So P Istio in, P Istio out. So they are the pod side of the virtual Ethernet pair. Okay, I'll go very quickly now. So I have 5 minutes, and if there's any question, I know there's a lot to process, a lot to digest, but it's fun. iptables are fun if you into some kind of fun. I will just quickly introduce the IP set. So there's how does it work? How does the Ztunnel knows what to do with the traffic once you get it? It's through another mechanism called IP set, which is a way to store information about what to do with the traffic. And these are all, so these are rules for the nodes to know what to do with the traffic once you get it. So, and this use this marking of the traffic, and you can tell that. And again, this is quite the thing. So these are the rules on the node, and these are specific. They mean something. So 200 is traffic coming out of the Ztunnel. 40 is, I think, traffic coming in. I don't remember by heart. And then you can have, if you look at the routes, so IP routes show table 101, which is this one, the one marked with 100. You can see that this is one of the pods, and so there is a rule for every pod to know what to do with the traffic. It's a bit, we can leave it. So this is the full iptables dump. of course, you see there is some what's it mean? Conmark and contrack. So conmark and contract are iptables mechanisms to store the connection tracking. So you can follow the flow. So the iptables, the kernel can follow the flow of the packets and trace it. And mark is conmark. There's somewhere. Well, for example, this is a rule, iptables rule that marks packets that come in through that rule and assigns this mark, and then the Ztunnel can know what to do with it. And you can also, and these are all the Ztunnel iptable rules. So I know it's a lot. It's a bit. I wanted to go overboard with the explanation, but this is how it works. So when a pod wants to make a connection, of course, looks up the IP address of the server that wants to reach, in this case, HTTP bin. So looks up the IP address, and then through the virtual address pairs, the kernel looks up the destination IP. And if it's part of the mesh, it sends it to the Istio out and then inside the Ztunnel pod. And eventually, if the HTTP bin pod exists on another node, there's a tunnel between the Ztunnels. So it's called HBone. So it's a multiplex tunnel between all the Ztunnels in the cluster, and the connection goes through that, and the Ztunnel will happily connect the pods together. And that's how you do mutual TLS. So between the Ztunnel and between an application that's part of the pod and another application part of the same mesh, you have this mutual TLS. It's all managed by the Ztunnel through CA certificate authority and so on. It's another topic for another talk. We have a few minutes, 1 minute. So the waypoint proxy is this layer 7 processing. Please go ahead and do the tutorial because it's very complete and there's a lot to learn there. So, but that's how it works. It gets same thing. The Istio CNI, when there is a waypoint proxy, when you create a layer 7 policy for a specific application, then a waypoint proxy is deployed. Is just a pod with Envoy, and it just intercept the traffic. So Ztunnel knows that instead of sending, because there is a layer 7 policy in place, instead of sending the traffic directly to the pod with the application pod, goes through the waypoint proxy and does everything for enforcing this layer 7 application policy. eBPF, this unfortunately we don't have time. So eBPF is, of course, it's a way to run programs by the kernel. So the kernel will run your programs whenever you want, whenever there's a syscall, whenever there's a signal from the kernel, this little program will run. So eBPF is, of course, very popular now. Everybody's talking about it. And we're also very, very involved in the eBPF and Cilium. Cilium is a CNI based on eBPF. So eBPF and Ambient is a work in progress. There is a GitHub issue you can follow. The thing is, like, eBPF, Cilium through eBPF does exactly the same thing as Istio CNI. It plugs in all the pods and network interface. So we are still figuring it out exactly how to coexist with Cilium, but eventually we know that this is the direction the community is going. Cilium is also a CNCF project, so we do want to, and it's probably gonna happen quite soon, having eBPF Cilium working nice with Ambient, and that would be another reason to celebrate another talk. So, thank you.
Questions.
Yes.
I'm going to
Oh,
do it very, very quickly.
Sure.
I'll take over screen share.
Yes, please do.
Just do these two well, you have the mic.
with an ambient mesh versus pod mesh or sidecar, I guess, what is expected performance improvement in terms of measured latency and compute cost? We did publish a blog about this. It's hard to quantify. It depends on your scale, right? So the more you scale, the more you have to pay for these sidecars, right? So it really depends on how many applications you onboard on the mesh, but it's definitely sizable. I don't remember the numbers, but they are quite significant. So you may not feel the pain for a small cluster, but when you scale out, it's definitely much better to have a single proxy per node. You wanna take this one?
Yeah, I mean, I just want to add on to that first question there. If you think about the resource allocations and the actual usage of the resources, every single one of those sidecars is part of those resource allocations. You're going to bump that up, even if you aren't actually using that. So in terms of the scheduling that the kubelet can do, there's a lot more flexibility, and your clusters can now fit more in because you're not allocating resources that you may or may not be using. That's the only thing I want to add on to that one.
Yes, well, it's an interesting one. Of course, Cilium is a bunch of things. There is a Cilium CNI, Cilium Service Mesh is also part of the project. They are commercial product built on top of Cilium. So Cilium Service Mesh is purely based on eBPF. So there is no proxy, or the proxy is done in the eBPF layer, right? So it's an approach. We have another one. I think we believe it's having a specialized proxy, especially for the layer 7. I think we believe that Istio Ambient Mesh is superior, but it's that's why CNCF is so big, because everybody has a space. And we love Cilium. We absolutely support the project. We contribute to it. Service mesh with eBPF, sure, it's a possibility, but yeah, it needs to be proven to be efficient. Yeah, thank you.
Round of applause, please. Thank you very much, Alessandro and Declan. All right, this is my one. We are now going to go to our second speaker. So, Ryota, please round of applause, and over to you.
Okay, hello everyone. Can you hear me? All right. So thank you for coming to my talk. It's a Midsummer Night's multi-cloud stream. Cross-playing with GitOps is like fairies with magic. I'm Ryota Sawada and from Upsider. So just briefly on agenda. So I'll be talking about myself and what Upsider is, and about this talk, what this talk is about and what this talk is not about, and a bit of love, magic and chaos with Terraform. And we'll go into Crossplane and GitOps shortly, and then we'll go into demo, and we'll have a bit of a summary at the end. And you can find this slide with the dub.sh/CNL Cloud Native London -2023 Crossplane. So a bit of introduction. So about myself, I'm Ryota. I'm the platform engineer at Upsider, and it's not Upbound, and I should have chosen my topic wisely, but Upbound is the provider or the creator of Crossplane. I'm just an end user from Upsider perspective, which I'm going to talk about. I'm passionate about learning, building, and sharing all things technology, and that's why I'm here to share my learning from using Crossplane and GitOps. And I have a son and 2 cats, and you can see quite a few cats over my slides. And the top right picture is what I use for my profile all over the place. And you can find me at usual places with RYT SWD, which is my full name without vowels. And Upsider. So it's a fintech startup providing B2B payment solutions, adopted by 20,000 plus companies, and headquarters based in Japan. And for that reason, a lot of users, most of the users are in Japan, but the team is remote, and I myself am based here, and remote team around the world. And cloud native end user from early 2019. So it's been a while, and we use multi-cloud and multi-cluster system, and we are hiring. So if you have If you're curious about what we do, please come to me after the talk. And about this talk, so I had a difficulty choosing the right title. So I just went ahead with a Midsummer Night's Dream kind of topic. Does everyone know about Midsummer Night's Dream? A few nods and a few like shaking the heads. So I asked, what can you summarize A Midsummer Night's Dream by Shakespeare to ChatGPT? I had to, and it was so long that I couldn't even read it. So it's here. If you want to read it, you can, but you can probably just do it yourself. And I asked, make the summary extremely simple, as short as possible. And I got this. In the Midsummer Night's Dream, young lovers and craftsmen wander into an enchanted forest where fairies cause mischief. After mix-ups due to love potions and spells, all is set right and the characters return to Athens for a triple wedding celebration. So I think that's really good. That covers most of the stuff. I went ahead, make it even shorter, less than 10 words, and it gave me not a sentence: love, magic, forest, fairies, play, chaos, resolution, celebration. So love, magic, and chaos are really good combination that I wanted to kind of capture that from, my talk. And I even went ahead, can you make a 3-word summary for nerds? And it said, fairies relationship patch. Okay, that's a good one. So this talk is about fairies relationship patch, a multi-cloud provisioning, and to patch or not to patch. So about this talk, a bit of prerequisites, basic ideas about infrastructure as code. IAC is probably good to have, a bit of Terraform understanding, and Kubernetes. And this talk is about Crossplane, obviously, and GitOps. And we'll be looking at the power of YAML and considerations to make for adoption. And this talk is not about Crossplane deep dive, GitOps deep dive, creating modules, or production-ready setup. So with that, I have some demos set up in my repository, which reminds me that I have to start my cluster before getting into this. So let me just, give me 1 second. So I have nothing, and we'll start kind clusters, which I will probably be adjusting here and there during the talk, and we'll go into the full-fledged demo later on. It's me. I should check time as well. Okay, so love, magic, and chaos with Terraform. So quite a few of you use Terraform, and I think a lot of you have at least used Terraform at one point. So love with Terraform, I just looked at the Stack Overflow 2023 developer survey that came out probably a few months ago. And there is this section of other tools, which is a really broad category, which I don't really think it's useful. But Terraform is up at the top for the provisioning solutions that I could find it in the list. So Docker at the top, if you can see it at the top right, and NPM and stuff like that. But Terraform is down at the bottom in this screenshot of 11.3%. And compared to other solutions like Ansible, Puppet, Chef, Pulumi, definitely a leader in that aspect. And Crossplane doesn't even come up. So I thought, okay, why not to have a talk about it? And when it comes to Terraform, a lot of people like it. So it's not just Terraform being popular about just hype. It's about there is the section called Desired and Admired in this developer survey from Stack Overflow. And desired is what people want to learn. And admired means that people actually like it after using it and they want to keep using it. So Terraform is pretty high, 68%, which is quite high compared to other solutions like Docker. I mean, Docker is pretty high. But give me 1 second. And one of the things that will be interesting to see is that the Pulumi is not so much desired, but it actually is very admired. 60% people actually like it. So that's an interesting learning, but Terraform is definitely a leader in the space. Okay. And magic with Terraform. So Terraform provides most of the provisioning needs, such as state management, locking, reusable modules, and etc. And Terraform Cloud even make it easier. So you can do state management, locking, and all of the things based on the cloud solution that's managed by HashiCorp and provides the Terraform. And Terraform Registry allows sharing module provisioning specs. So modules, you can share that on Terraform Registry, and some of them are verified by HashiCorp, so that it's something that you can kind of rely on official kind of supported spec. But there is a bit of chaos with Terraform that I have to admit. I have been using Terraform quite a few years already, and the talk is about Crossplane, but I will also touch that Terraform is something that I use day to day. But Terraform is a bit of a difficulty by itself. Is mainly based on HCL, HashiCorp configuration language, although it is a relatively simple language, and I think you can probably pick it up about like in a day or so. But it does have some learning curve to it, some like counting and enabling, disabling, stuff like that. And Terraform Plan and Terraform Apply are the key kind of interface that you work with. And the Plan being different from Apply is something that a lot of you probably have faced in the past. And Terraform state and lock management is great for working as a team, but also you can sometimes find yourself doing force unlock, making sure that you can actually work on Terraform state or locks. And while Terraform module and registry allow code reuse and module sharing, they can be quite complicated, because if you were to have the module that supports all the different use cases, you can have different labels, different flags. And I have personally found that it's difficult to kind of go through the modules, and like it would be easier to just write it myself. So with that, I would like to go into Crossplane and also GitOps. So what is Crossplane? So Crossplane is a Kubernetes operator for resource provisioning. And in their own term, like Crossplane's official kind of website has this term, universal control plane, and it's to check, report, and act on any resource. So it's not just a cloud resource or like AWS or GCP. It says like it can do anything. And they even say that they can like order pizza, which I don't really know how it works. But it's something that they kind of brag about. And it's about declarative configuration with YAML. So it doesn't have HCL, it doesn't have any DSL. It's basically YAML, which is something I'm going to talk about a little bit later. People might have opinions, but stick with me for now. And Crossplane being a control plane, it periodically checks resource state and updates as necessary. So that's about kind of like acting on it, acting on resources and checking and reporting. But also it means that if the things get drifted from the desired, well, if the actual provisioned resource get drifted from the desired state, it will be rolled back and it will be updated accordingly. So that's very Kubernetes-like, and this is something that will be very interesting to look at from the provisioning perspective. And the one or two things that I need to kind of mention about Crossplane is that there are two or kind of 3 or 4 terminologies that you need to be aware of. One is composite resource, and people would call it XR. And composite resource and several associated resources, which are composite resource definition, which is referred to as XRD, and also a claim. And they are basically about the same thing, but they are about building your own controller with YAML config. So it's very similar to CRD. You can think of the XRD basically exactly the same thing as CRD, but it's also gives you the power of writing the CRD without writing CRD kind of. And composition is a list of managed resources. So based on the definition that you have in XRD, you can create the managed resources. Let's say you have S3 bucket with IAM roles and stuff like that that you need to create at the same time. You can have that defined in the composition. So it's kind of a module, you can, like in Terraform world, but it's also a YAML file that kind of we'll have a look a little bit later. And what is GitOps? So I need to touch on the GitOps a little bit more as well. So it's probably quite a few know what GitOps is, but just a bit of refresher. GitOps is managing to manage resources declaratively by reading Git commits, and it monitors resources for diff and drift and patch automatically. So it's kind of similar to what we saw with the Crossplane, but obviously this is a Kubernetes kind of control loop. And Argo CD and Flux are both CNCF graduate projects for GitOps, and almost magical how it makes the resource management seamless. And we'll be looking at Flux this time. I think Argo CD is so popular that people don't really need to have another demo on. So we're going to with Flux, which reminds me I need to run the Flux commands. So I have the kind clusters up and running. So if I can just type out a bit quickly. Okay, so I've got 3 classes which I created earlier, and I'm going to run the Flux Bootstrap so that I can get some time bought by that, and then go back to the slide. So we'll talk about the Flux a little bit more. So yeah, another bit of a quick intro about, a quick guide about what the demo is about. So we'll explore 3 cloud providers, AWS, GCP, and Civo. And so we'll have 1 kind cluster per provider. And so that means I would have 1 cross-plane control plane. So cross-plane is an operator. So I'll be installing the operator into 3 clusters, each one kind of managing each environment, which you don't have to. You can have 1 operator to manage all the resources from GCP, AWS, Azure, or whatever that may be. But I just decided to go with 1 cluster per resource or per provider, which is just easier to see in action. And this is exactly how we do at Appsider. And composition to create network, cluster, and all related resources for AWS and GCP. So that means that I will be using some kind of moduled approach for AWS and GCP, which we actually use at Appsider, which we will have a further look. And for Civo, Civo did have the Crossplane provider, but I think they have not been maintaining it too much because their focus is not right now in Terraform. And from that, we worked with Civo actually to work out our own provider based on Terraform, which I'm going to also talk about. And this one is going to be pretty simple, and we'll have a managed resource directly. So with that, I'm going to go into the demo, which will kind of see all the code and config around the Crossplane. And I think it will be quite difficult to hold my mic and talk about stuff. But so first of all, let me just get back to, oh, not the summary yet. So the repository is like that, Crossplane example, and it's got a few directories, and I haven't really put up all the information in the README, so I'll be updating that after the talk. And in a few days, you can expect to have more information about how to run it, how to fork it, how to run your stuff based on this. But as I said, this is not production ready setup. This is something that you can experiment with, but it's not something, you can just have it as your go-to place. It's just for your learning. And from that sense, let me go back to the terminal. So Flux is all done. So what I'm going to do is to see what I have running. Okay, I'm going to do one by one. So AWS cluster is up and running with Crossplane running and Flux being installed. So essentially what I have done is to run Flux Bootstrap command, which will be easier to see in a different window, but it's Flux Bootstrap GitHub and then owner of Appsider without E actually, and repository of Crossplane example, exactly the GitHub repository we were just looking at. And also this one is looking at the Flux/GCP directory. And again, it's a cluster that I created with Crossplane for GCP. So if we were to go back to the code, and this is the actual GitHub repository, and we were seeing the Flux/GCP in the path. And this is all the Flux definitions of installing Flux, but at the same time, we are installing Crossplane on top of it. So you can kind of see how Flux does it from the code or kind of directory structure. It does the pull in the Flux definitions of the actual control plane and all of that. Nothing very fancy or anything different from the official way. And you can see that the Crossplane is here, which does the pull in the Crossplane Helm release. So based on the 1.12.2 Crossplane release, and it will be installing that based on this YAML and also the Helm chart. So you can kind of see, or you will be able to see in the GitHub repository how this is all mapped out. But what I want to see is not the Flux bit, but also but the Crossplane bit. So in the Crossplane directory, I have AWS and Civo and GCP. And GCP side, there is this, well, like all the directories would have something similar, but looking at GCP specifically, there is this compositions, and then you have the essentially modules in the Terraform world, what the cluster would look like, what it would mean to create a cluster, how many resources you need to create, what it would mean to create an IAM network and stuff like that. So if you were to look at cluster, there are two things. So we looked at XRD, the composite resource, and also composition. So we'll start with the XRD. XRD looks like this. So this says composite resource definition at the top, and it's got the name and claim names and all of that. And then after that, I'm saying that this XRD is based on, or is version 1 alpha 1. And in there, I define what are the fields that I can provide to the cluster. So it has ID, it has some parameters. If I were to create a cluster in region of Asia Northeast, which is Japan, I can specify that, or I can specify something else, and Kubernetes minimum version, CIDR, range, firewall, and all of that. So this is an input definition that you can provide in the XRD. Let me just put that away. And so it is very verbose, and I don't think that everyone actually likes it. It's a bit difficult to manage and configure if you were to really kind of have really complex setup like cluster, because cluster is not just about GKE, it's not just about EKS, it's about network, it's about IAM role, it's about nodes, node pools, and versions and all of that. So it is quite lengthy, and what it would look like for actually creating resources is what's defined in the composition file. So the composition file is this kind composition with quite a few resources. You don't have to look at the patch sets for now, but the resources, you can see that in this particular GKE cluster definitions, it's a standard cluster that we defined. This is very similar to what we actually use internally. It's got the cluster, which is the GCP cluster, which is essentially GKE. And it's got a node pool. And if you want to have multiple node pools, you can, but you have to define it in the YAML file like this. Firewall, keyring, and this is about encrypting some of the database and some keys. If you were to do that, you have to provide some KMS setup. So you have to go through all the different resources, but at least you can see that everything is defined. Nothing, no magic has happened, like nothing is created in some situations and not created in some. You can see that the YAML is the go-to, and it's a golden source that everything is defined in. So you can see that service account, project, and crypto, Kubernetes provider config, and all of that. And what I'm going to do is to go to actually to Civo. And if I go to the projects, so I've got this customization, which is completely removing all the cluster and firewall network setup. If I were to put that back in, save that, and then push that over. So if I do customization, what? So if I commit that and then push that over. So if I were to go back to Civo, which is this one. So I don't have any cluster running right now. And if I go back to the Civo K9S and then Civo, so Crossplane is running. And if I do Civo, firewalls is okay. There's nothing in there. And if I were to, oh, it just happened to sync. So basically Flux does the sync about every 10 seconds and the Crossplane does every 30 seconds. So that you can see that firewall is being created. It's not yet ready because it has to create a network first, and then we'll be able to create a firewall. And on top of that, you will be able to create a cluster. So if you were to go into Civo network, and it's failing. And I know exactly why. This is because I haven't created the token, the key for it. So I've got the key already in my environment. So I'm going to do the export and like that. And it would create the key for connecting to Sivo from my cluster on my kind. And hopefully it will be able to pick up and create the external name, which means that it's got the network. And if I go to firewalls, it's probably taking a little bit more time. Let me just get that away. And so essentially what I'm doing is, actually I should go into the code for Sivo stuff, sorry. Instead of using the composition and XRD, what I did with the Sivo setup was that directly using the managed resource Sivo Kubernetes cluster or Sivo firewall. And this is something that you can have it as a part of the composition or kind of a module so that you can deploy all the things at once. But it is likely that you would probably want to have network and then you have multiple clusters inside of network. And in that sense, it might be having the module is not the right way. And this is one of the ways. And also I'll be probably preparing something for creating clusters in AWS and GCP, which I could do if I had a token and everything set up, but I don't. So I will be probably working on that in the coming days, and we'll be providing some references and some kind of guidelines in the repository after this talk or in a few days' time. So if you go back to the firewall, it's up and running. So if I go to Sivo Kubernetes cluster, it's not up and running. And it's trying to sync. So if I go to Sivo website, at least I should be able to see the network, which I can. So Crossplane example network is the name that I created for. And the firewall is also associated. If I go to Kubernetes, it's provisioning. So it's something is happening. So you can kind of see how this works with the Crossplane without using Terraform at all from the code perspective. So with that, let me get back to the slide. Yeah, let me get back to the slide. So quite a quick recap. So it's YAML everywhere, whether you like it or not. It's all resources are defined in YAML. And Crossplane plus GitOps is a declarative provisioning, which I didn't actually do. But if I were to delete the cluster from Sivo, which would mean that it would recreate without me doing anything, because it would check that Crossplane would check the desired state and also the actual state. The cluster is not running, then it would try to create again. So from that sense, everything is very GitOps-like, very Kubernetes-like if you were to use Crossplane, which is not something that you can get with Terraform, but with a bit of kind of automation magic you need to provide. And it is something that we need to consider for upgrade and downgrade. Whether you use a module or composition, you need to make sure that you can upgrade and downgrade for the provisioned resource. If you were to do a lot of code reuse and modularization, it might be difficult to downgrade if something just didn't go the right way. Cloud-specific adjustments, we just looked at Sivo and GCP. And GCP composition was quite complicated, and AWS is even more complicated. So you can have a look at the composition definitions in the repository. But in order to, this is really cut off. So it says it will be easier to manage each cloud separately, which is exactly what we do at Upside. We don't try to do everything in one composition or one XRD. We would say that AWS has these specs that I would care about. GCP, I don't. So from that sense, we separate all the directories. Maybe it might be easier to manage all in one, but we found it easier to separate. So it might be different up to your needs, but it's something, our repository should be a reference point. And it's YAML everywhere, so it can be a dream or nightmare. People like it sometimes, and some people really hate it. I personally like it more than some magic happening behind the scenes without the declarative setup. So yeah, it's a preference, I guess. And things to note, so with Crossplane, we saw that the basically apply happened the right way. So there is no plan phase of Terraform equivalent. So Terraform plan, you would see what will be provisioned, and the Terraform apply, you would do that based on plan. That's not happening with Crossplane, and I don't think that's possible. Crossplane does give you the immediate application apply happening basically to the provisioned or the provider, which is good that you can actually see things in action. But if you were to upgrade or downgrade, you might want to consider doing something more than just applying it and hope for the best. You might just see things, go north. So from that sense, yeah, it's just one thing to note. It's not fit for everything, and you can use both Crossplane and Terraform at the same time, which is exactly what we do at Upsider. We don't do everything in Crossplane, but we do use Crossplane for things that we don't want to have any drift, such as IAM. So we want to make sure that the access control is always right. And every 30 seconds or so, Crossplane does check the desired state and also the actual state. If there is any diff, then it would roll back or apply the patch, whatever necessary. So from that sense, Crossplane is great, but Crossplane is not great for something like AWS SSO or like organizational patch, organizational setup. So from that sense, you might want to still use Terraform along with Crossplane. And you need a Kubernetes cluster, and that I use kind cluster. And if you were to really provision for production use case, you would want to probably create the cluster from Crossplane and then install that Crossplane on top, like over to the provisioned Kubernetes. It's kind of chicken and egg problem, but you can do that. And if you do that, you have everything managed from Crossplane, even the Crossplane cluster itself. So you could do that, but you need to have a cluster running, which is maybe something that you may need to maintain, maybe a bit of a pain point. There is no loop in the YAML file. So like, because it's a YAML, because it's declarative, you can't just say, okay, I'm going to create 3 clusters or 3 networks, subnets and stuff like that. You have to define everything one by one, which is bit tedious, I have to say, but it is also fully declarative in that sense. We saw the Civo example. It was actually Terraform provider that was used behind the scenes. So while I was interacting with Crossplane, everything behind the scene was actually done by Terraform. So you can use the Terraform's Terraform community's abundance of APIs and providers by using Crossplane, and you're not really losing anything from using Crossplane. That is based on this project called Upjet. You can look up, and Crossplane is very tightly coupled with this project, which is basically getting the Terraform code into Crossplane. You have a few more kind of advanced usages with the composition function, which we are not using, and we don't have any examples for, but it's worth figuring out if you were to go down the Crossplane journey. And also Argo CD, if you were to use Argo CD with Crossplane, there is a one gotcha that you need to go kind of figure out. There is a quite clear documentation that have been put in place in the recent days. So definitely check out if you were to use Argo CD. If you were using Flux, it would be quite simple, and exactly Flux Bootstrap would do it. But with Argo CD, there's a bit of catch with it. And with that bit of references, so this repository was the Upsider github.com/Upsider without E, so UPSIDR /Crossplane example. And this slide deck was w.sh CNL Cloud Native London -2023 Crossplane, and some tools used for reference. And thanks to my team who have helped put together the slide. And with that, thank you very much for attending.
Thank you. Thank you so much. We are running a bit late, so I'm going to skip questions. Unfortunately, I know there were a few, but hopefully you can ask them directly to Ryota. We are going to now take a break, come back for 8 o'clock. I think there might still be some drinks and cake and whatever upstairs, so please go, feel free, help yourself. Toilets are in that corner over there. I will see you at 8. Thank you.
Yeah, I'm going highly different. Of course, yeah. It's yeah, thanks. Yes, thank you. Thank you. Yes. Okay, I'm gonna go and get some water. Yeah, now's the time. How do we get some of that? No, or maybe even have like admin. They would get all well, you need them. Yeah, like people. Yeah, great.
Yeah, I think it will be great. I think what's you know, come a long way to the lessons from that because we haven't been so late and even got all these error. Yes, like just like finding ways to make so one of them is there are some obviously that's huge. But yeah, that maybe it was there is a target. He's always yeah, I didn't realize that thing when you had to layer secondary proxy. Okay, set up. And the layer secondary. It does. It's the best you did a great job. It's so much effort. That's what when I used it long it's a company that I get response. And so I use adequacy and thankfully. You have to use using but no one if we actually well,
yeah. Why in person? Yes. No.
The other ones in France.
Yes. Yes. This year some servers. Oh, okay, yes. Okay, so
in return certain things. The resources to make
What did I run? And it's very
We're going to kick off again in a minute. Please come on down. I know there's like half the people still upstairs. So thank you for coming down. I think we should probably just kick off and then let people come down when they're ready. Is that okay? All right. So please welcome Christian, our third speaker of the evening. Round of applause.
Yeah, thank you, everyone. Thanks for coming back. And yeah, I'll try to be on time and not go too much into detail. So let me know if it's going over. So I'm going to speak about how you can optimize your applications using continuous and profiling and profiling alone. Yeah, so my name is Christian Simon. I'm working at Grafana Labs, software engineer. I've worked on the Loki team before I switched into our profiling team. Earlier this year, we acquired a company called Parascope. So our previous product was called Flare, and now we're kind of merging it. So you will find, if you Google for the GitHub, there's conflicting information. So it's our focus to sort that out over August. I'm coming from the kind of Kubernetes cloud native space. So and that brought me, just the complexity of Kubernetes and all the associated services brought me into the Prometheus space and eventually into Grafana Labs. And yeah, now I'm here and talk about profiling. So let's maybe take a quick look through observability in general. So everyone knows logs, everyone uses logs, most applications hopefully emit some logs. And that's usually something where you can figure out something's gone wrong for a user. Maybe there's a timeout, a 500 error, something along those lines. Through metrics, you get like more an overall picture. You have heavy aggregations, like you figure out maybe for multiple users something is wrong, maybe not so much for the individual anymore. And for example, you would investigate those slow responses, like why are they in my system? You will find a histogram that kind of points to a problem with your basket if you're an online shop. And maybe if you use a later version, for example, of Prometheus, would have exemplars pointing you to a trace that explains a bit more what's happened, like in the kind of context of all your microservices. And so eventually, the trace would tell you something is wrong with that service. And then, like, I would say maybe the metrics point to there's some CPU overload. And then, like, most common option is probably scale up, give more CPU, just run more of it. And what I want to show with the help of profiling, we can actually have an alternative to scaling up, maybe scale up now, but release a new release 2 days later that optimizes the exact problem you were hitting and run at lower scale, make more out of your resources. So profiling alone obviously looks at the resource usage down to the kind of code level granularity. You typically measure things like CPU or memory usage, and it will highlight kind of how long specific parts of your application take to run, or how much resources they take to run. With continuous profiling, you look over that like all the time, ideally, or at least a huge subset of your applications. And with that comes the problem that like there's actually some overhead. Like if you want to record every function call, you have another function call that records it and so on. And so you need to kind of think about like, what do you want to record? So usually at latest at continuous profiling, you would introduce some sampling to only really collect the resource usage for things that are big enough, you care about it enough that this actually makes a difference for the whole system. So like other than just like the resource efficiency, you can also like make sure that like your latency is better. Obviously, like less CPU cycles translate at least in some ways into lower latency. And it also can help you to figure out what your pods are actually doing. So like you might see, oh, there's a lot of CPU going on. I have no idea what's happening. Looking at a profile will tell you at least in which line of code that has been occurred. And especially in an incident, you might get some better pointers where to look at what recent code change, like do git blame, figure out when the last change of that line of code has happened. And so it can help you, yeah, to fix kind of production issues quicker. So yeah, when you kind of start into continuous profiling, exploring Grafana, for example, you would typically find you have the kind of query thing. You select your from and time range where you want to look at. You know kind of roughly when the problem has happened, and then you would select the labels that yeah, you figured out through either logs, metrics, or traces where the problem is. Like you don't have to. You can try to profile everything, but it might be yeah, going under in that huge amount of data you get back. And then once you get the result, you get the resource usage over time. And the bottom bit is like the flame graph or the top table. The top table is an aggregate, so the time doesn't really is not reflected. It's just the sum over everything. So the resource usage usually helps you to maybe select the time from 12:30 to, I don't know, 12:39, wherever you see some anomalies. And then by looking into the flame graph, you actually would find out which line of code, which function name first, and then from there going down further into detail. So I hope it makes a lot more sense after I go through a small example. So like a very simple Go program that basically like starts with a main function, does a lot. Before it does a lot, it prepares and then does little, and in the little, it also has to prepare. So let's say we want to measure CPU. Kind of the main function spends 3 CPU cycles. Then the do a lot prepares, spends 5 CPU cycles, and then does a lot. So we can see kind of that recorded in a stack trace notion as main spending 3. I'm kind of in the way. And then do a lot prepare spending 5, do a lot 20. And that's kind of how you would formally kind of note it down when you actually profile a real application. Obviously here in the table, with 5 stack traces, we probably easily can spot what's happening. Sorry? So that's kind of Go syntax. So I also have a demo somewhere, like I think it's linked at the very end. And then to visualize that better, there's kind of the flame graph. So that is kind of that example as a flame graph. And so you can see we start with the total, and the total is also the main function, because the only entrance into this program will be the main function, so it's 100%. And then what you're kind of looking for is for boxes, leaf boxes that have like quite a lot of space underneath 3, because that's where the function actually consumes things. So for example, the main function, if you remember, has 3 CPU cycles. That's the 3 here. So it's not that much. If you compare it with do a lot, which has 20. And usually colors mean nothing or different things for the different profiling solution. Like in that case, the colors mean the same package name, the same function name. So for example, the prepare here has the same color, but that is nothing to rely on. So we're still thinking about what the right thing is there to visualize it. So you can also like later on kind of go to that link, play with that example around in a more dynamic way, and we're going to look at real flame graphs later as well. So I'm a developer on the PowerScript team. It's written in Go, so that's where most of my expertise lie. But I think you can easily kind of adapt this to other languages as well. But Go basically, like, for example, provides you with the standard library with the CPU profile. And what is measured in the CPU profile is the So the Go scheduler knows 3 states for its Go routines. And those are either, oh, sorry. So I got that MacBook 24 hours ago. So I'm coming from Linux. I have no idea. So let's skip this. So you might see a lot of control C's and command whatever. So I'm still struggling. But yeah, the CPU profiler basically looks every 10 milliseconds at what is executing. And executing is like a specific thing, like which is not IO or mutexes or channels. So if the code is blocked, it will not be counted as on CPU time. So you will not see everything. Like if you have some form of IO problem, like it might look like the application has a lot of CPU usage. You look into the profile, there's nothing there, I guess. And that kind of is always something you need to keep in mind. And that's different for a lot of languages. As you can see, that's heavily relying on Go having the scheduler and scheduling their own Go routines. But that's basically the state with the CPU profile. You also might see actually the Go runtime being part of the CPU profile. And one of the most common things you will see is garbage collection being part of that. And that brings me to the next profile type, which is it's the memory heap profile. So basically, like Go's memory profile don't really kind of take care of anything else than the heap. So the stack, for example, is ignored. But on the heap, it measures 2 types of profiles, the allocations and the one that are in use. So allocations is everything you allocate since the start of time of the program, while in use is minus the one you have read or garbage collected since you allocated. And also in this case, there's some sampling going on. So remember the CPU had like every 10 milliseconds, I'm looking what I'm doing. So there might be things in between the 10 milliseconds you lose. And the sampling mechanism, like I'm not a mathematician, but there's some Poisson sampling used. And every 512 kilobytes, basically there's one sample generated. And that then is internally translated into the kind of estimate of how much it is in real values. Like while you only see where the allocation really happens. So like you do a make slice, string slice with 1,000 elements. That's the kind of code position you see. But then there might be reasons why it's not garbage collected and it's still there. And you have no way of figuring that out through the profile because it will only record the allocation, not where it's referenced. And you need to go through the source code and find out where you forgot to dereference something. So now I'm going a bit closer to the real world. So compared to the do little, do lot example, it's still only a demo app, but basically that app passes a JSON file of Nobel Prize laureates and then just outputs one random one. And I purposely didn't kind of maybe write it in the best way, at least the version 1, so we can see kind of a bit, yeah, how that looks like for real software. You find the demos in that GitHub repo later, and I'm gonna have a try now. So I guess that's roughly the source code. It's 100 lines. You have a handler, which then parses that JSON and selects kind of one random laureate, outputs it. So if we actually want to kind of call it, so it seems to work. So it seems kind of snappy, so it's not wasting too much time. But so I think the JSON file in total is like 300 kilobytes. So there's really not too much to be done. So now I'm kind of going to the continuous profiling, and I have some load generator that just calls that, I don't know, 20 times a second. And obviously now as a start, I need to kind of select what I want. So the app is called price, and I would use the allocation space profile type here. And so now I can see kind of the flame graph from earlier. Before we look too much into it, so I have a couple of versions deployed. So I just want to see version 1 for now. And here we can kind of see the flame graph view. So you can see it kind of the entryway is through the HTTP handler and then going into Nobel Prize past prizes. And there is where the majority of allocations happen. So you can see the whole program, like over the kind of time I'm scraping it, has used 10 gigabytes of allocations, and 1066 and 1005 have happened within that Nobel Prize handler. So this is probably the thing where I should focus my work on. It's a clear indicator here. And then if you go further down, so you can see OS read file reads the file into memory. There's obviously a huge part here. There's nothing underneath. So just maybe something I should reconsider. And in the same way, everything here is encoding /. So it's in the Go standard library, doing some decoding of JSON, I'm assuming. So when I then looked at the source code again, and with the information of the profile, so we can see that that's the read file. And basically what that line does, it reads, I guess, everything of the JSON file into memory. So I thought like, maybe this is not the best way of doing that. So I came up with a version 2. And so you can see the new version is on top, the old version is at the bottom. So you can see I replaced it with an OS open. So create a reader interface that I then put into the JSON decoder rather than the on Marshall. So like it only reads bit by bit. And I deployed it, and let's now look at the kind of difference. And so while here we were in the kind of single profile view, we also have a comparison view where you can compare 2 profiles. So like you will see the differences highlighted. So I'm trying to do that now. So that's basically like the selector for the left side and the selector for the right side. And now I'm changing this one to version 2 here. And it can also be used for different times. So I need to kind of slightly adjust the timing to overlap. And what I see now is, so what is red has been added, and what is green has been removed. So I guess I removed the read file, and I removed the JSON unmarshal, but I got the decode. And I don't know, it's probably bigger. So it was not really kind of what I was after. And I think that's kind of like probably the first reason, or the first case why you should use profiling. You should never assume. Like I always use the open file and think it's better. But obviously, like in that case with the allocations, it clearly isn't when you actually collect the numbers. And so I went with my version 2. So I was obviously seeing the huge JSON block, and probably let me control. Okay, I think. So the read file is made a comeback, but after Googling a bit, I found out there's the JSON iterator library, which is the best, and like whatever. So let's use it. It seems to be a huge block of allocations within the JSON standard library. Maybe this is kind of improving my situation here. And when I now go back to select the different word. Okay, 1 moment. So go back to allocation space. On the left, I take version 1. The right version 3 with the JSON meter. And I guess we see again. Sorry. There we go. We see again quite a lot of red, more red than I would like. Just like, let's make it a bit better. So we basically just replaced the encoding /JSON with JSON iter library. It's roughly the same size, if not bigger. So again, we appear to not have won that much. And so like now I kind of, when I went for my fourth version, I actually thought a bit outside of different libraries and outside of the box. And obviously I'm doing kind of the same work like thousands of times, really unnecessarily. So I basically just cache the past JSON. And obviously like I would have known that without profiling in a simple case, but I think if the application gets more complex, yeah, you kind of miss those things. And then, yeah, if you want to take a quick look here at the actual profile. So we kind of get the green you see, like, so obviously like no allocation is necessary. We just read the same JSON object that we kind of keep in memory. Yeah, at the beginning at my versions 1, 2, and 3, I was looking like Katy Perry, and now I'm happy that exactly what I expected happened. But that is only one angle. We only looked at memory allocations now, and especially when the kind of Go process gets hammered, like an extra cycle of garbage collection will make things a lot worse. And so, for example, I also mentioned I'm running a load test. And now I looked at the load test results. And I was kind of a bit more satisfied again with my solution. So we can see the, well, the top one is the kind of initial version. We can see kind of response times of 15 milliseconds, roundabout, up 20. We can see version 1, version 2, so the one where I replaced the read file with the open file and do like a IO reader decoding. I already get kind of 5 milliseconds off. So yeah, that is quite satisfying as a result. And with version 3, the JSON iter shaves off even more, like a fifth of the time. So there's clearly something to that library like that Google suggested. And then obviously like the cached version does absolutely nothing. We are 0.3 milliseconds in that case. And like, I guess, like with that learning in mind, I looked maybe back at the CPU profiles, and that's definitely where you can kind of see where this libraries shave off the time. So I maybe just let's compare the version. Oh boy. So I hope my Mac adoption makes me quicker at some point, but no, I did the comparison here. And so here we can see that in terms of time on CPU, it's already kind of reduced with JSON iter like. So this is now the time. Before the width was bytes, now it's time. And so you can see kind of like the green things we shaved off from the built-in JSON on Marshall library into the JSON iter. Yeah, just one point in the slides. So I guess in terms of takeaways from my little kind of Go demo, so always kind of measure, because like I would have assumed different things. Like I maybe would have been happy with the latency improvement of 3 milliseconds, but not really understood that I didn't really shave off the allocations. I think, like in my experience, focusing on allocations in Go, especially on quite CPU-heavy services like our databases, get quite a lot of base load. Every garbage collection cycle that you can delay, like will shave off a lot of kind of extra costs. Like when you do garbage collection, you lose your CPU cache and like all sorts of other things happen. And like there's definitely a quite positive effect to reducing those. And basically, like, still the best optimization is the work that you don't have to do, don't do. So like, as we saw kind of in the caching example, that was obvious. In other examples, it's maybe not so obvious. But, and I think one rule that is also quite important is first check the profile before you optimize, because maybe it's not even measured in the profile and everything else is way bigger than the thing you do. So you saw at the beginning when I looked at the open file and like those other candidates, definitely don't forget that step. And I think if you want to learn more about kind of profiling, but also like Go performance in general, like Dave Cheney has a really great workshop. I think it's from 2019, but like still really relevant, and like definitely go through at least parts of that. I think that can be quite useful just to understand a few more things. And yeah, so how to use it today. So I mentioned we are kind of developing right now in Grafana/Flare. Next week, the week after, we hope to move into the Pyroscope, and so we're trying to join the best of the two worlds. Like there were a couple of different ideas, and obviously we also learned what we maybe not do in the next version. So basically, like maybe from next week on, we have kind of the first early Grafana Pyroscope versions in our weeklies. And you can also use our free tier in cloud, which comes with profiling. Like it takes away, I guess, the work to set it up, and it should be enough for a couple of pods, I guess. And I think that was it in terms of like, you can contact us, me, I guess, on our Slack, like anyway, like I also put it up on GitHub, that example, if you kind of want to recreate it in Docker Compose. Yeah, that's a playground URL. And yeah, I think that was it.
Questions for you.
Yeah.
Right, a couple of questions. Yeah. Do you need any instrumentation of your application to get to continuous profiling?
Yes and no. So there are different ways how you get the profiling data out. The examples that I used, Go has like kind of its own instrumentation implemented. So I had to only import a standard library, I guess. Like what you often find when you instrument it, you get more language specific information. So the only other route, I guess, towards getting without instrumentation is through eBPF. So we definitely, I think it's very well tested for CPU, but like you won't get that kind of memory allocation information. Like it's quite language specific. Like I don't think it's impossible from what the people that do eBPF say, but it definitely is not as general right now. I think with CPU, that's just like everything created for you. Everything you still need to figure out kind of how the stack traces look like, the stack backwards and so on. But like, I think that is well understood for most languages. So yeah, yes and no, depends on the language. I think, for example, for JVM, it will be really hard, I think, to not instrument. And obviously you have the agent there on the JVM. And so I think over time, I would hope the answer is no, I think, for even this more specific profiles. But yeah, for now, probably yes, especially when you want heap memory information.
And then what new letter will you add to LGTM for profiling?
Yeah, so like, I don't know, I'm not speaking for the marketing department. So they didn't like that idea. So our internal project name was Fire, and like we saw us like maybe Worry to the L looks fucking good to me, or was kind of our thinking process. And then like, because it's low-key logs, metrics, so we had to have the P, so we had the PH. But yeah, I don't know at this time, but like, yeah. So like, I think if it's there, it will be LPGTM.
All right. Okay, thank you so much. Round of applause, please, for Christian. So that concludes our meetup for this evening. I want to say thank you once again to our speakers, to Ryota, Alessandro, and to Christian, to our sponsors for this evening. Thank you very much to you guys for coming and spending your evening with us. Hopefully I will see you again next month. If I'm not around, then I'll see you in a couple of months' time. We are going to go to the conductor, to the pub now. Feel free to come along, hang out, and just chat with more people. Otherwise, have a very good evening. Good night.
Thanks. There was like there was